Hello scientists, Ms. Getz here. I know lots of people have been absent from class, so I wanted to make it easy for you to catch up with classwork and take notes on the notes that we've been working on in class about how do we calculate energy. Because for our roller coaster project, we need to know how to calculate how much energy our roller coasters have. So we are going to learn that today, and you can take notes either on the physical paper copy. If you are at Harding, you can get a paper copy from your teacher, or on the digital copy of the notes so that you have it in Notability. So you know about energy already. We've learned all about it in class. And in science, we describe energy as anything that has the ability to change or move matter, so it can change matter or it can move it, or the ability to do work. If you think about all the different types of energy we've learned about, this will describe all of them. Sound energy, well, that's producing a change and it's moving matter, the little particles of air or anything that sound is traveling through. Light energy, well, that's producing a change and it can do work with something like a solar panel. So all of the different types of energy we've learned about fit in this description. Energy is measured in joules. And this is said joules. It's spelled a little bit differently than the sparkly jewels that you might have in jewelry, but it is said joules, and it's the unit for energy, joule. It can be abbreviated with a J, a capital J, and it's made up of newtons and meters, which means that energy has to do with force and distance. And when you get to physics class as a junior or senior, you'll learn way more about that. But that's about as deep as we're going to go here in physical science. So you want to double check that you've written down your definition of energy and the unit joules. And then we're going to go on to gravitational potential energy. So gravitational potential energy, as you know, is a stored energy. It's a potential energy. It's not doing anything yet. And it's dependent on the height of an object. So however high up the object is, tells you how much gravitational potential energy it has. Sometimes scientists call it the energy of position, based on what position the object has, or its height. And we can calculate it, which is awesome, because we need to be able to do some energy calculations for our roller coasters. And it is the mass of an object multiplied by the acceleration due to gravity, how much gravity pulls stuff down, accelerates it downwards, and multiplied by the height of that object, because again, it's dependent on the height in meters. Now, you don't want to have to write out all of this when you're writing a calculation. And so scientists shorten things with an equation. mgh is our equation, so it means mass times the acceleration of gravity times height. And the acceleration due to gravity here on Earth is always 9.8 meters per second squared. Always, always, always here on Earth. If we're looking at a different planet, this would be a different number, like Mars might be 6 meters per second squared. But here on Earth, we're going to be doing all of our calculations, so it'll always be 9.8. And again, if you haven't seen this in math class, having letters next to each other like this means that they're multiplied together. So it's mass times gravity times height. Just as a reminder for you. So we have a little practice problem. And this practice problem is all about the power tower at Valley Fair. Dun, dun, dun. And so I have some information for you here about the power tower. If you've never been on it, it's a ride that lifts you up, 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 up. And then you wait here at the top and eventually it lets go and you drop to the bottom. And it slows you down at the bottom. But at first it's just you're dropping and falling. And it's gravitational potential energy, which is making you fall. So we want to calculate how much gravitational potential energy each of these 3 cars on the power tower have. So that will depend on the mass of the people, the acceleration of gravity, which is 9.8 meters per second squared, and the height. And we're going to assume that each car and the passengers is like about the same mass, 600 kilograms. But notice they're at different heights. So car 1 right here is at 55 meters, car 2 is at 40 meters, car 3 is at 33 meters. I'd like you to take a moment and write down a prediction for which car you think will have the most gravitational potential energy. Car 1, car 2, or car 3, and think about why. Pause the video if you need to. Awesome. So let's go ahead and calculate how much gravitational potential energy each car has. Just like usual, we're going to write down everything we know. We're going to write down our equation. And oh, hey, I already wrote it down for you. We're going to show our work and what our answer is with the correct units. So from the information they gave us, our knowns include the mass of each car, the acceleration due to gravity, and the height of each car. And you can actually go ahead and fill in the other two heights here. I'm going to let you do those problems. But I'm going to talk about car number 1 with you right now. So I know the height of car number 1. I know what equation I'm going to use to calculate gravitational potential energy is mass times acceleration gravity times the height. And I'm going to show my work right here. So I'm going to write down GPE equals, write down the mass of the car, the acceleration due to gravity, and the height of that car. So then I've written down the calculation I'm going to do so that I know and future me knows what I did and my teacher does too. And then on my calculator, I'm actually just going to type in 600 times 9.8 times 55. The meters per second squared sometimes trips people up. This squared here only belongs to the seconds, and you don't need to worry about it when you're doing your calculation. So I've typed that in on my calculator. I hit equals, and I get 323,400, and I'm all done, right? Wrong! No, I need the units. For energy, the units are always joules. So I'm going to add in a J for joules as my answer. You should pause the video here and calculate for car number 2 and car number 3. Good work, scientists. I hope your answers matched mine. If you are off a little bit, double check that you typed in 9.8 instead of 98 on your calculator. And also double check that you changed the height for each car. Those are easy things to get a little mixed up with. So we can see that car number 1 has the most gravitational potential energy, and that's because it's the highest up car. So good work. You can now calculate gravitational potential energy. You want to flip over or go to the next page of your notes sheet. And we're going to talk about kinetic energy. And kinetic energy is the energy an object has because of its motion. So anytime something is moving, it has kinetic energy. And we can actually calculate how much kinetic energy we have using this equation that says 1/2 times m, that stands for mass, times v, that stands for the velocity, how fast the object is going, squared. So I'm going to take the velocity and I'm actually going to square it. So that means that actually kinetic energy depends more on the speed or velocity of an object than on that object's mass. And you can pause the video here if you need to finish taking your notes on this page. Make sure you've got this equation written down. It's really important. So let's do a little bit of practice. So maybe you've been to the bowling alley before and you've noticed that they have different masses of balls. And I want to know, does a bigger bowling ball always give you more kinetic energy to knock down the pins? So I'm going to help you with this really quick sample calculation. We've got 2 of them to practice here. And so I've got the first problem, which says your teacher rolls a 5 kilogram, that's my mass, bowling ball with a velocity of 8 meters per second. So I wrote down the equation I was using. I wrote down the calculation, what I need to calculate. And now I'm going to think about how to type it in on my calculator. Well, 1/2, that's the same thing as 0.5 or 1/2 of 1. So on my calculator, I'm going to type in 0.5 times 5, the mass, times 8 squared. So I can use, sometimes calculators have a squared button. Sometimes you need to use a little caret and then a 2. Or if you're using a very simple calculator, you might just write 8 times 8 because squared just means you multiply by itself again. So I typed that in on my calculator and I got 160 joules. take a moment to try calculating the second one on your calculator and make sure you feel comfortable typing it in. Awesome, I hope you got 147. If you didn't, double check that you typed in 0.5 as 1/2 and that you squared the 7 meters per second. So either 7 with a caret 2 or it would be 7 times 7. I hope you got the same answer as I did because I have one more set of practice problems for us to try. And that is comparing Simone Biles, the greatest gymnast of all time, with a sumo wrestler and predicting who has the greater kinetic energy. Do you think it would be Simone Biles, who has a very small mass but can move very fast? Or the sumo wrestler, who has a very large mass but moves pretty slowly in comparison? So I, again, have a calculation set up, started for you. And you want to take a moment and write down the knowns on your calculation paper. And I know the mass of the sumo wrestler, and I know all this other information. So I've written that down, my velocity, the mass of Simone, the velocity of Simone. Excellent. Then we know our equation for kinetic energy is 1/2 mv squared. And so to show my work, I'm actually going to rewrite my equation just so that it's a little bit easier for me to see. So I rewrote it. And then I'm going to write down the calculation I'll do here. So that'll be 1/2 times 120 kilograms, the mass of the sumo wrestler, times 2 meters per second, which I'm going to square. Then on my calculator, it's going to be 1/2 as 0.5 times 120 times 2 squared. And then I'll hit equals. And I get the answer 240, and you think, am I all done? No, there's something important. Do you remember what it is? It's the units. You're right. So I need to include the units, joules, on my answer. Then, scientists, I'd like you to try calculating Simone's energy, her kinetic energy, and figure out who does have more kinetic energy. You got this. Pause the video if you need to. You probably need to. It's like not an easy calculation, but you can do it. Good work, scientists. So I would like you to make sure that you have these notes either in your lab notebook or on Notability and easy to find. And then you're going to submit your kinetic energy calculations to Schoology 7.1 if you're in my class. If you're in someone else's class, maybe you'll do something else. But good work, and a way to learn how to do calculations for gravitational potential energy and kinetic energy. Keep up the hard work.